Hi everyone, this is Savannah Bekowski, Project Assistant at the Syracuse University Environmental Finance Center. On behalf of the Environmental Finance Center Network, I'd like to welcome you to our webinar entitled Water Audits and Water Loss Control, Entering Your Data into the Spreadsheet. To give you all of an idea of where others on the webinar are tuning in from, we have prepared this map. You can see that we have attendees spread all throughout the entire globe. Thanks to you all for joining us today. This session is one of several webinars conducted by the Environmental Finance Center Network for the Smart Management for Small Water Systems project. The EFCN provides training and technical assistance to small public water systems in all 50 states and 5 territories to help local water systems achieve and maintain compliance with the Safe Drinking Water Act. Attendees can receive a certificate of attendance for viewing this webinar today. This webinar has not been submitted to licensing agencies for pre-approval of continuing education credits. AWWA recommends that you check with your licensing agency to learn about its criteria, rules, and what you need to do in order to receive credit for your attendance. It is your responsibility to verify this information with your licensing agency. If you need assistance in applying for credit to your licensing agency, please contact educationservices@awwa.org. You will receive an email from AWWA 10 to 30 days after this webinar with a link to access your certificate. And here are the small systems program teams. You can see that we have environmental finance centers spread all throughout the country, from New York to Kansas to California. And here are the areas of expertise that the EFCN focuses on. Workshops, trainings, and direct technical assistance are provided on asset management, energy management and planning, rates and finance, leadership through decision-making and communication, managing drought, water loss reduction, collaborating with neighboring communities, multi-funding, water conservation, management and finance tools and techniques, climate change resiliency, and workforce development. The EFCN also provides a small systems blog. You can learn more about water finance and management through this blog. Blog posts will feature lessons learned from our trainings and technical assistance, descriptions of available tools, and small system success stories. You can view this blog at the efcnetwork.org website. You will also have the opportunity to subscribe to this blog at the end of the webinar. In addition to workshops, direct technical assistance, and webinars, as part of the Smart Management for Small Water Systems project, we are also creating a table that lists the major funding sources for drinking water infrastructure projects in each state and territory. And here's how you can access those tables. From the homepage of the efcnetwork.org, you can go to Resources and then click on Funding Sources by State. This will take you to a map of the country. If you click on the state you are interested in, you will find a PDF table of that relevant funding source for drinking water infrastructure for that state. The table looks like the image on the left hand of the slide. For each funding program, it will include the name of the program, a short description, and contact information for someone who works in the program. And at this point, I would like to turn the presentation over to our speaker for today. Today we have Heather Himmelberger, Director of the Southwest Environmental Finance Center. We also have Dawn Nall with us today as our question and answer moderator. Dawn is a program manager at the Southwest Environmental Finance Center. Heather, welcome, and take it away.
All right. Just give me a moment to show my screen here, and then I'll put it on. All right, well, good afternoon, everybody, and welcome to today's webinar. This is part 2, and there may be a part 3. That's something we'll talk about in a moment. I just wanted to remind you that you can type in questions as we go along. So if you look at the chat box at the bottom of your control panel, anytime that you have a question while we're going through the webinar, please go ahead and type it in at that time. A very, very brief review of water loss and auditing is how we'll start today. So if you remember what we talked about last webinar, if we take our water produced minus our water sold to our customers, what we end up with is non-revenue water. And we really want to keep that concept in mind. If you have in the back of your head the terminology unaccounted for water, you want to strike that from your memory banks. We're not using that terminology anymore. We now have better terminology, and we want to think about it as non-revenue water. So what does non-revenue water include? It includes the water that we use for our city, town, municipal purposes that we're not billing for. So maybe you provide water to a fountain in the middle of town, or to City Hall, or to a ball field, or something like that, where you're allowing the use to go on, but you're not billing for it. It also includes illegal water use, so people who might be stealing water out of your hydrants, or illegally connecting to your mains, or stealing water by tampering with a meter, something like that. It includes water that the utility uses for flushing and other purposes. So if you flush your lines, or if you do street sweeping, or flush sewer lines, anything like that, where you're using water for utility purposes, but it's a occasional use, and it varies from place to place. It's not like the use for the municipality where you're always watering a certain place, or you're always sending water to a certain building. It also includes poor data handling. So if you have practices that create errors in your data, you transpose numbers, you have mismatched time frames, different things like that, where your data isn't being handled in the best way possible, you might create some errors, and that will also show up in the non-revenue water number. Inaccurate meters will show up there, so if you have customer meters that are reading inaccurately, that is going to show up in our non-revenue water. And finally, what we think of the most when we think of subtracting our produced water minus our sold water is the water that we lose through pipes. Again, one of the reasons we really want to stress the non-revenue water idea is to let everybody know that it is much more than just the water that you're losing through the pipe. So yes, that is one component, but there are 5 other major components. And we want to be very careful to consider all of those components when we think of our non-revenue water, and not just water that's leaking from pipes, services, and tanks. So why do we care at all about this understanding, this non-revenue water issue? Why do we want to understand it? We really need to know how much water falls into each of those categories, because there are very different tools that get applied depending on what your problems are. So the tools that you might use for real water that's leaking from pipe is going to be very different from a tool that you might use to address water theft. So we have to be clear on where our water is going, because we may apply the wrong solutions and then not get the results we want, and not reduce that non-revenue water number. We also want to understand our non-revenue water because it teaches us a lot of things about our facility. As we go through and try to collect the data for the water audit and the water audit process, we will learn a lot about our facility in a lot of different ways. So when we think about a water audit, what we're trying to do is complete a water balance, or determine where our water is going. So all the water we put into our system, which is on the left-hand side, and all the water we send out of our system on the right-hand side, we're trying to balance these out. So the concept of a water audit is that all columns are going to add up to the same amount of water. So it allows us to balance one type of water use against another. And so if we have our sources on the left-hand side and our uses on the right-hand side, they are going to equal. Why do we care about this? Because we can determine the real losses through subtraction. We don't actually know, or can't estimate very well, what the real losses in our system are. So what we can do instead is, by knowing the different columns and what they add up to, for example, how much water we supply to our system, and then knowing all the columns, all the little boxes on the right-hand side of the different uses for our water, we can subtract these boxes from the water supplied and end up with a number for the real water loss. So the idea of a balance is the way we can determine how much water we're actually losing through real losses. So we don't actually input the number of real losses into our water audit. We only get it through a calculation. The water audit software helps us determine what the balance looks like. So we don't have to enter the information into that balance that I just showed you. We can enter it into this free water audit software that was developed by the American Water Works Association. So let's have a quick review of the necessary data that you need to put into your water audit. We talked at length about this in the last webinar, And you're welcome to go listen to that recording to get some more information about the data. But what we want to note is that the data falls into 5 distinct categories. So we have data regarding the water we supply, data regarding the water we deliver to customers, data regarding our water system characteristics, financial information, and then we have a category we just call other information. This is information that's good to have to kind of back up the water audit and to provide some additional insight into what's happening at your facility, but wouldn't be directly input into the water audit. So something that falls into that category is break data. We just talked about the fact that we do not enter directly the amount of loss through leakage, but what we can do if we actually have break data, the way we can handle that is comparing that data against what we see in the water audit and having that help us determine how to handle the real water losses. Again, we had a webinar on March 1st that was recorded. You can access that on the efcnetwork.org website and listen to the recording. We focused heavily on gathering your data. Today's focus is going to be moving from that data into the water audit and putting the data into the spreadsheet. We may end up having a third webinar because in only an hour you can't cover everything, so there are some things that had to be left out of today's webinar program. So because of that, we'll probably look at having a third webinar to cover some of those aspects, and that'll probably be in a couple of months. So be on the lookout for an invite to our third webinar. Okay, let's move on to entering the data into the software. So again, the software is free. You can download it. You'll just have to register, but the registration process is free, and you can access the AWW Water Audit software there. You can go to awwa.org, and you can either search for the water audit software, or you can put the / water loss control, and that will help you find it a little quicker. Either way, you can get to it, and it is an Excel spreadsheet. You'll need to have Excel on your computer in order to use the software, but otherwise it's free. One thing I like to comment to people is that it's not as bad as it looks. It looks a little scary when you see the spreadsheet. It looks like there's a lot of work involved. And there is some work, and it will take you some time and effort, but it's not as bad as it first appears. Some of the items aren't going to apply to your situation. Other items have default values to help you get started. So there's probably going to be about 10 to 12 overall inputs that you have to come up with for your audit. And you'll learn a lot about your system by doing the audit, so it's still worthwhile to go through the process and learn about your system as you go. And don't worry, the first time through it may not be the best audit, but over time it will definitely improve. So beginning the water audit, we want to go to the instruction sheet as the starting point. It's very important that you go here. You may be tempted to say, if it's instructions, I don't need those, I'm going to move on. But your water audit won't work properly if you don't visit the instruction page and enter some of the information there. So please go to the instruction page first and start there. You'll enter your contact information and system information. This information is just who you are, your email address, the name of your city or utility, your city, town, your state, and then your PWS ID number if you know it. Then it will ask you to choose a calendar year or a fiscal year. You have your choice of saying, do you want it to go from January 1 to December 31, or do you want it to be a fiscal year? You might choose a state fiscal year, which are typically July 1 to June 30. You might choose a federal fiscal year, which is typically October 1 to September 30, or you may have any other fiscal year. I've worked with many utilities that have different fiscal years starting in August or starting in April. So whatever you have, if you pick a calendar year, that start date and end date box will go away because it will just assume January 1 to December 31. If you pick a fiscal year in the select type box, then you get to put in the start and end date, and you can have them be whatever you would like. Then you have to pick your volume reporting unit. So what do you want the water audit to be in? So it can be in units of millions of gallons, megaliters, or acre feet. Those on the East Coast probably aren't very familiar with the terminology of acre feet. Those of us out west use it quite a bit. It's a measure of water withdrawals. I have seen most commonly, about 99.99% of the time, people choose millions of gallons. And even out west here, when we use acre feet for withdrawals, we typically choose millions of gallons. But there are these other two units, megaliters or acre feet. The main thing to note there is that you want every unit to be consistent. So if you use millions of gallons, that is the unit that will carry through the entire audit. So there's not going to be a mix and match. You're not going to use acre feet for your production number and millions of gallons for, you know, customer supply. You can't do that sort of thing. You have to choose one or the other and stick with it through the entire process. So here's just a completed instruction page. I've just filled in some information just to show you what it looks like when you're all done. And the key things that you have to do here are the millions of gallons and the audit year. Some of this other information, if you don't put it in, they'll just be blanks on your water audit. But you have to pick your volume reporting units or it's not going to work properly. The next step is to develop your inputs, and this will be put in the reporting worksheet page. So the starting point we're going to look at today is water supplied. So the very first part of the water audit and the most important part of the water audit is the volume you're supplying to your customers. So in this, there's three different factors: the volume from own sources, the water imported, and the water exported. So let's start with volume from own sources. We have chosen millions of gallons, so we're going to look at trying to develop a number for the millions of gallons that have been supplied from our own sources for the entire year. So as an example, here's some data from a water utility that shows 3 different wells. They've collected data on a monthly basis for how much flow each well has produced, and you can see the total by well for the year. Then what we need to do is take all those totals, which we now have for wells 1, 2, and 3, total it all up by the month, and then total for the entire year. So for the entire year we have 16,896,500. What we need to do is remember that we're not putting in that direct value. We need to put in millions of gallons. I've had a couple of utilities make that mistake where they put in that 16,896,500 number, and then their water audit is way off. So you have to be really careful to convert the number to millions of gallons. So all you have to do is take your number of gallons divided by a million. So in this case we end up with 16.8965. The software is not going to let you put in quite that many decimal places, but just so you can see the calculation there of how we got to the number of millions of gallons. We would then input that number into our software, and you can see right here, volume of own sources, we put in that 16.89. If you put in the 8965, it'll just convert it to 3 decimal places and make it 0.897. So the monthly readings provided us the necessary data, but did they tell us the whole story? So we had these monthly readings from each of our wells, and that did give us the information we needed to put into the water audit software. But there is a little bit more to the picture. So one thing to think about is reviewing that monthly data to see if it makes sense to you. So here's a community that we have worked with, and we've taken their monthly data. This is actually a different community than the data you just saw, and we've plotted it out over the year with the production data showing on the orange line and the water supplied to the customers as the blue line. So you can kind of see the pattern, and this is typical of a Western utility where the flow goes way up in the summer and it goes down in the winter. So they would be able to look at this flow pattern and say, does this seem to make sense? Are there any strange anomalies? Are there any months for which the data doesn't seem to jive with what I would expect? And then they can go back and look at that data. The other 2 lines you see here are actually starting the next fiscal year of 2017. These are 2016 data. So as these get populated, you'll start to see the yellow and gray lines populate across. So something to think about is graphing your use over the year to just see if the pattern makes sense. If, for example, we had I think this is July. If we had July's data showing way down here and we showed a decrease in usage and we were in New Mexico, that would be telling us that that's probably not a correct reading, something is wrong. If we ever see times where the production falls below the customer, that's another thing we might want to check into. So this is just one way to help us determine if that monthly data makes sense. Another thing to think about is daily reads. So if we have monthly reads and they're backed up by daily reads, that's the better option. We really want to have daily reads because they add value to what we're trying to do. So there are many benefits to having daily reads, and I put a few of them here. Without the daily reads, there's really no way for us to tell if our monthly readings are accurate. So if we had that graph that we just showed, there's really not a way to tell. It might be off by 10% or 5% on a monthly basis, and I wouldn't really know that because if it stopped reading for several days during the month, I might not know that the meter cut out for a while because it wouldn't be enough of a difference in the monthly total to really alert me. So the daily readings really help us verify what the monthly readings show. There may be 0 reads with master meters where they miss the monthly total, that are missed within the monthly total, and this is a lot more consequential than if you had an individual customer reading 0 for 1 month. You know, if you have 500 customers and one of them is on 0 because the meter failed, you're not going to have a huge problem. But if your master meter is on 0 for, you know, several weeks and you don't know it because you're only doing monthly readings, that could be a real problem. And alternatively, there could be some spikes that are high due to an electrical or equipment malfunction, and you're not going to know that if you're not doing daily readings. Another time is when the meters turn over or new meters installed. You can fix the data to make sure that you have proper information. And the daily reads allow you to have the same time frame between customer reads and master meter readings, and this is especially important if you want to look at water use or non-revenue water on a monthly basis in between doing your annual audit. So the audit we're talking about is annual. We're looking at the entire year, and we don't recommend using that audit software for, say, doing a monthly audit. But you may do some spreadsheets or that type of thing where you're looking at your data on a month-to-month basis. If you read your customer meters, say on the 20th of every month, the daily reads will allow you to match your production readings with your customer readings. So that would be a big benefit if you want to look at that non-revenue water on a shorter time frame in between your water audits. So the daily reads also provide a lot more information about the system, alert you to problems much, much sooner. So if there's a failure or a component issue with your meters, you're going to know a lot faster if you're doing daily reads and you can address the issue right away. So we highly recommend taking daily readings of your master meters if you're not already doing so. And here's just an example of when the meter turned over. If we don't notice this, we end up with some crazy data down below where we get some negative production numbers. When we do see it through our daily readings, this is excuse me, a situation of daily readings, they can correct for that and deal with the fact that it was a meter turnover. Another issue with the daily reads is if you see zeros, one thing you can look at is whether the zeros make sense because we weren't using that well, or whether those zeros are incorrect readings. So if you have your pump runtime records that you can compare to your production records, you can see that the pump wasn't running, and therefore it makes sense that it's 0. Or if you just know the operations and you know that you only run it every so many days or something like that, or every other day, you can check the 0 reads and make sure that they fit what you're doing with your system. However, we want to look at any issues with data handling errors. Here's an example of handwritten daily reads that were then transposed into or typed into a spreadsheet so that you could create some master data or some monthly and then annual data. And you'll notice 3 of the reads were actually incorrectly entered into the computer. These are fairly minor for this month, but it's something that you would want to correct and check because if this happens every month, it could add up to a lot of water. So in this case, the 3 reads that are off are over by about 20,000 gallons. That's not going to be noticed given the total water, but they could be more significant. So keep in mind that as you're putting numbers from your handwritten records into the computer, you may introduce errors, and you want to be on the lookout for that sort of thing. Once we get our information in there for the volume from known sources, we want to move on and look at any master meter supply errors. So the meters we generally believe will not be completely accurate. They're going to be off by a little bit. We won't know how much unless we actually test for that. So here's an example of 6 wells and the meters and the testing that was done to come up with a variation in how much the meters were off and whether they were under or over reading. In this case, we have 4 that were under reading, 1 that was over reading, and 1 that was pretty much spot on. We only have the opportunity to put in 1 number. So that means we have to do a flow weighted average for what that variation or percent off is, and we have to know whether that's an over or under. So if it's under reading, it's going to be a negative number. If it's over reading, it's a positive number. And we have to figure out what the total flow per year from each well, then the total of all wells added together to let us have a percent of how much of the flow is coming from each well. So you can see that calculated there. Then we'll multiply the percent of flow per well by the variation, and then add up the final numbers to get our negative 5.05 that will go into our audit. So we'll put that number into the audit software, and then you can see it actually corrects for the error. So we were saying that it was under reading by 5%. So the water audit software gives us a higher number for water supply. Remember, we started out with 16.897, and it corrected for us and moved the number up to 17.795. So once we know what the error of our meters are, the water audit software will take care of correcting for that. And we recommend an annual testing of the master meters, just so that you can check each year how far your master meters are off. And again, this is such an important number in your water audit software. It sets the balance for the whole rest of the water audit, that it's really important that this number be as accurate as possible. If you have any water imported, you would follow the same process to calculate your total flow per year. You would have meter readings from the meter you were using to import water. Daily reads would give you more information, so again, you may want to consider daily reads if you're not already doing that. But you put your 1 number for how many millions of gallons you have from imported water, and you use the same meter error process. So if your meter is checked, you can put in the error that is calculated or that is determined from the testing, and the water audit software will correct for any errors from the meter. Same with the water exported. We would use the same process to check our meters for export water and to check our meters for accuracy, and we would put that information. Again, remember, 1 number for each of these categories goes into the water audit for a total for the year. So the water supply will be calculated based on what we enter, based on whether we import or export or have our own sources. You may have 1, 2, or all 3 of these numbers. You can have any combination of them. You can have any combination of the master meter supply errors. And one more thing to note is you're also welcome to click on this button that would allow you to change it from a percent to an actual value of water supplied per year. So if that's an easier number for you to come up with, you can also do it that way. Next up, we want to look at customer data. So we want to look at the water that is billed and metered, billed and unmetered, unbilled but metered, and then unbilled and unmetered. Those are the 4 categories we're going to focus on next. So we're looking at customer data for the entire year. Now, unlike the production meters, generally speaking, we only have monthly values for the amount of water our customers use. So we'll read our meters once a month. Some people only read meters quarterly, and I have heard a few systems that are only reading them semi-annually, but that's a little more rare. With the new metering software, it is possible, if you have an automated meter reading system, that you may have more data than just monthly, but that ends up being a tremendous amount of data. So generally speaking, you're not going to look at every single one of your customers on every single day of the year. You're probably only going to go into that more precise data for customers if there's a reason to do so. So generally we're just looking at monthly meter reading data, and we want the entire year total for all of our customers, all the water we supply. And again, these are people that we send a bill to and we meter. So in this case we have a number of 118 million gallons. If you look over here, you can see the number before we converted it, 118,926,700. We divide by a million to get the 118,926. And I do want to point out that this is different data, a different system than the data for water supplied. We would enter this data into the software, and again it only lets us have the 3 decimal places, so we put 118.927 into the software. Then it starts to calculate for us the authorized consumption. You'll start to see this yellow box get filled in. An example I wanted to show you of customer data that allows the system to look for anomalies is shown on the screen. This is a spreadsheet we created for a utility that was looking at their customer meter data, and they were having some issues with 0 reads, low reads, high reads, but it was difficult for them to sort of pick out which reads were the most important to go investigate. So we have some information, monthly totals here, and then the yellow boxes are anywhere where the percentage is less than is 10% less. The pink boxes are when it's 30% more than they typically have used. And then it also gives you some information here whether the customer is 50% above or 50% below the average usage for that area. And you can change the percentages up here in the pink box and the yellow box to being anything you want. But with this, a utility could enter their data on a monthly basis, and as they see the yellow and pink boxes pop up, they can see if that makes sense, they can check into it, they can look and see for customers who are way above the usage or way below the usage what might be going on. If it's way below, they might want to check the accuracy of the meter just to make sure the meter's working properly, or they may want to investigate, maybe it's a household that has very few people living in it. But it just gives more information that allows you to react a little bit quicker. You know, if you see a 0 read and it doesn't make sense, you can send the meter reader back out. The 0 reads actually are red. It's a little hard to see on the screen, but they show up in red. So again, gives you more information and gives you the opportunity to look for anomalies in your water utility. We also have billed unmetered data. In this case, these are customers who get a bill but they're not metered. So it's going to be a flat rate that they get paid. Because we have no meters, everything that goes in that box has to be estimated, and it will be a rough estimate. We're not going to spend a lot of time today talking about how to estimate this. There are some actions you can take that are described in the M36 manual from AWWA. My advice is at least consider metering those individuals, even if you're going to bill them on a flat rate basis and don't want to bill based on volumetric usage. For water auditing purposes and water loss purposes, you may want to consider metering all of your customers. Now we have unbilled meter data. Now these are the people who were metering their usage but we're not sending them a bill. So these might be people like your city hall, maybe it's your fire department, different people that you have chosen for a policy decision to not send a bill. And that's up to the governing body of the utility to decide if anybody's going to get unbilled water, and if so, who that's going to be. What you need to do, however, is to at least track those meter readings. Here's an example of a utility that has a bunch of unbilled meter data. They've collected data for the year, for how many gallons they've used. You really want to consider reading those meters as often as you read all the other customer meters, and then total the entire flow for the year to see how much water it is. In this case, it's 1.72 million gallons. So what you want to think about is that a lot compared to how much we put in the utility? And what is the value of the water that we've given away? So how much is that worth to us? And this is more to get back to the policy piece. Somebody somehow has to pay for that water. So that has to be factored in somewhere in the rates of others to cover the water that is not being billed. So it's important just to have transparency in terms of how much water, who's getting it, what the value is so that the governing body can make informed decisions about how it wants to go forward. The billed unmetered data goes right here into the third block down, so you can see the 1.722 going into that block there. And then the final one is the unbilled unmetered data. We have two choices. We can either use the default value, which is 1.25% of the water supplied. And if you don't know anything about what you're doing that's unbilled and unmetered, then the best idea is to just choose that default percentage. The folks who made up the water audit software used a lot of utilities to kind of figure out what a nice, good value for that percentage would be, and an average utility is, that's a really good starting place. However, if you estimate the values from that type of flow, you can actually use real data. So as an example, you may have, on a monthly basis, you're tracking how much flushing you do, how much sewer flushing, the fire department and what they use, and you can come up with the total value of water that equates to. Now, one thing to remember is that you do not want to include any estimate of leaks in this number. Some people get confused because it's unbilled and unmetered and they think that a leak fits in there. The difference is unbilled, unmetered in the water audit software is authorized consumption. We do not consider leaks to be authorized. We don't really want them to be occurring, so they do not fit in the unbilled, unmetered data. So if you're collecting any information about leaks, you do not want to put it in this portion of the audit. So if we put in the value, we have to choose to click here for the value. You can't change the default percentage. So if you want to put in your own information, you have to choose this button and you fill in your value, and you can see it show up here in the yellow box. And then the other option, as I mentioned, is to click this button or leave it the way it is originally when you open up the software. It'll be the 1.25% and it puts in that number 1.764. So you have the two options and you can start with one and move to the other if you would like. The next step is our apparent losses. So we have a choice to put in unauthorized consumption. Again, we kind of have two choices. We can either put in a default percentage, which in this case is 0.25%. And it's sort of assumed that all utilities have some level of unauthorized consumption. Even if you're trying your best to try to prevent it, there's going to be somebody sneaking water somewhere. If you have a more significant problem with theft and you've identified, people who are stealing water and you have some idea of how much, you can change, again, pick that circle there and put in a value. Again, if you don't really know much about your system, the best place to start would be the default value. The next number you're going to put in is a customer meter inaccuracy number, and if you use the percent, it's a percentage from 1 to 10%, or again you can put in 1,000,000 gallons per year by changing to that number, and if you're way above 10% you would have to do that. Many utilities haven't yet begun to check inaccuracies in customer meters, so they would be basically guessing at what that percentage is. It's something to really think about going forward, doing a more thorough analysis of your meters, trying to do some accuracy testing, get a company to come in or buy a bench test or whatever you can to try to check your customer meter accuracy. And then the final apparent loss number is the systematic data handling errors. This is related to how your data is being handled, how you move it from one thing to another, paper to computer, or this program to that program. You can introduce errors. You may have some errors in the SCADA system or other electronics. So the default is 0.25%, the same as unauthorized consumption. You can use that default percentage as a good starting place. And as you go along, you may get more familiar with errors in your system. You can always at that point start to enter a different value by using the button there. So we have non-revenue water. After we've entered all those data points, that will show up at the bottom here. So our non-revenue water, which is kind of what we're doing this to figure out, will show up at the bottom. And then we have our authorized consumption number, which will show up there. An apparent loss will show up there. The real losses will be calculated by real losses equal the water losses minus apparent losses, so we'll get a value for water losses calculated by our software. Moving on to other inputs, we're not going to spend a lot of time on the system data just because an hour is not really enough time to cover everything, so we'll postpone looking at the system data in more detail later. I do just want to point out one thing. We had a question after our last webinar about the number of connections, active and inactive service connections, and I had mentioned that it is the active customers, inactive customers, and the number of fire hydrant connections. And there was a comment made that shouldn't be included, the fire hydrants, and I just wanted to point out that the M36 process does include fire hydrants. What it does not include is pipe distances to fire hydrants, which are included in the length of mains up above and the number above. So we do want the number of active connections, inactive connections, and fire connections to the utility in that box. And then our cost data is down at the bottom. And again, we'll cover this in the next webinar of how you will get your cost information, your customer, retail unit cost, your variable production cost, and all of that sort of thing. So gathering the data for our audit, we want to have our monthly water supply volume, our production meter testing results, the water volume sold by rate code by month, our retail rate schedule for the audit year, the total annual cost of operating the system, what we spent on power and chemicals in the audit year, what we spent purchasing water in the audit year, if applicable. So those would be cases where we had to purchase water from another utility. And other supporting data that we would like to have is customer meter testing results. And again, many utilities do not have these results. So that's a case where we might have to wait for that later. Pressure data, the quantities of unbilled, unmetered flow if we're going to move away from the default value, and then line break data records. And again, this is not going to go directly into the audit, but it's good information to have to kind of compare to your audit results. So the data that we have, is it going to be completely accurate? And the answer is no, probably never will be. You'll get it much better accuracy as you go along, but it's always going to be off by a little bit just because of the nature of what we're trying to do. We're talking about water going through pipes and lots of meters and hydrants and all kinds of things. The meters are not going to be 100% accurate. Our policies are going to be maybe not all we want them to be, etc. So we're not always going to have perfect data. The way we kind of address this in the water audit process is to have data grading. So you might have noticed on the spreadsheet as we were going through and looking at data entry inputs, there were little boxes to the left. So these little tiny boxes that are in the red circles are where we enter our data grades. So every time we enter a data input, we want to enter a data grade. So how do we know what data grade to use? You'll notice a little red triangle in the corner, and we will hover our cursor over that red triangle and up would pop a pop-up box that explains what the data grades are. The pop-up boxes can be a little bit hard to read and use in trying to separate out the various components that you have to meet to be that data grade. So we've actually come up with, at the Southwest ESC, data grading spreadsheets to help you select the right data grade. This is the same information that's in the water audit. It's just presented in a little bit different format to kind of help you get through the process of deciding what data grade is accurate, because we often see people reading just the first little bit of the data grade information in the water audit spreadsheet, and then they select the wrong data grade. So this process will help you try to avoid that. If you go to our website, southwestefc.unm.edu, you can click on Services and then Water Loss Control. And then once you pop up the water loss control, you can click on Resources. When you click on Resources, scroll down, you'll see Water Audit Data Grading Sheets. And there's a little description there, and you can click where it says Here, and up will pop our Word data grading sheets. You can either print them out and write on them in pencil or pen, or you can just put a check mark, insert a check mark in the box using the Word program, so whichever you prefer. There's one sheet for each data input. And the thing to note is that data grades are much more related to policies, practice, and procedures. So for example, the data grade for volume of owned sources is related to 3 basic things. The percent of water production sources that you meter. So do I meter all of my sources or only some of my sources? The meter accuracy testing and calibration of those meters, and then the actual accuracy of the meters. So based on your answers to those 3 questions, that will determine what data grade you are. What you want to do is choose a starting point. It really doesn't matter where you start because you'll move up or down from there. You'll read the items in your starting place and say if you meet or exceed the criteria, check the box. So for example, this one says 50 to 75% of treated water production sources are metered, other sources estimated. If I meter 75% or more of my sources, I can check that box because I've met or exceeded that criteria. I'm sorry, if I meet 50 to 75% or do more than 75%, I can check that box. If I can't check a box, like say occasional meter accuracy testing is conducted, maybe I have never done it, so I can't check that box. If I have a box unchecked, I need to move down to the lower number and see if I meet it. If I meet or exceed all of my items, if I can't meet or exceed, I will move down. If I can meet or exceed, I move up. So I'm going up or down based on the number of items that I put that I check. In this particular case, there are some areas where it will say conditions between 2 numbers. Then we look at, do we check everything in box 2 and anything in box 4? If we've checked anything in box 4, we would be a 3. If we've checked nothing in box 4, we're going to be a 2. Here's an example of where we've checked all of 2, 1 of 4. In this case, we would be a 3. The data grades get entered again into those little boxes on the left-hand side, so whether you use hours or whether you use the pop-up boxes, figure out the appropriate data grade, and you must have a data grade for every entry you put in there. The most important thing is to make sure you're honest about what the data grade should be. You do yourself no favors by choosing the wrong data grade because you'll make bad choices if you don't put in the right information. You'll think your data is more accurate than it is, and you might invest money in the wrong places because of that. If you forget to put any data grades in, the software will tell you, for example, we're missing 2 parameters, and they won't calculate your score or move on to your results until you put those in. Once you have put in all the numbers, it will give you a water audit validity score and tell you what you are out of 100. And it will also tell you the priority areas for how to increase your validity score. So if I was going to try to make this particular audit better, the volume from owned sources would be addressed, unbilled metered would be addressed, and customer meter inaccuracies would be addressed. These are the 3 biggest items for me. So if my score is 49, what response should I have? Well, I think what you should do is decide that the data is not quite where you want it to be to move on. We'd like it to be at least a 50, but you may even want to be a little higher than that before you invest significant amounts of money to address non-revenue water. But we'd like it to at least be a 50 before we kind of move on to the results. We'll talk a little bit more about data validity and moving on in the 3rd webinar that we'll schedule. So again, even though results will be provided, once you put in all the data grades and all of your inputs, you will get results. Don't put a whole lot of stock in those results if you have a very low data validity score. If your score is, say, 20 or 30, it's highly likely that those results are not correct, and you would want to go back and deal with your data before moving on to addressing non-revenue water. So beginning the process, what if you don't have any good data, you don't really know what's going on, can you really do a water audit? You have to start somewhere, so go ahead and jump in with both feet, put the data in there that you know, estimate the rest, and at least get your first audit done. You would not use that to make very big decisions in terms of expenditures of money, but that would give you the place to start to say, what data don't you have and what would I want to collect for the next year. So until you start your audit, you don't know what you're missing, you don't know what to improve. So I highly recommend you just jump in with both feet, start somewhere and do the best you can with the data that you have now, and then just look to improving it. It may take you a couple of years to improve your data. That's okay. Remember, again, just a reminder that it's not as bad as it looks. So it may look like there's a lot of information that you have to put in, but many of them are fairly easy to get. The system characteristics and the financial information is often not that hard to get. We have a couple of defaults in there. So by the time you're all said and done, you're probably looking at about 10 to 15 inputs, and a lot of that information you'll have at least some data for, and you can start with what you have. So again, you can improve it over time, and you won't know what to address until you just get started. And there are benefits to doing a water audit, and there's definitely benefits to doing one as opposed to just jumping to the conclusion of what to do. I've had several utilities tell me, well, we knew we had a high non-revenue water number, we decided to replace all of our customer meters, and it didn't get better. Well, the reason it didn't get better for them is that probably was not the problem they were having. So it's really important to do the water audit to try to put the water in different buckets so that you know what your problem is before you invest a bunch of money. So if you invested, you know, tens of thousands or even hundreds of thousands of dollars in new meters and it didn't solve your problem, that's a very poor expenditure. So you want to do the audit first before you start spending a lot of money on addressing your non-revenue water, or at least do it concurrently. Something else I like to always remind people is don't let what you can't do stop you from doing what you can do. So if you don't have all the information, if you don't have all the support you need, at least do what you can. At least look at areas where you can improve the data collection. Look at areas where you can enter data, address different things, see what's in your power, and worry more about that than what's not in your power. And think about what you can do at your own facility following this webinar. Really consider downloading the water audit software from AWWA. Take a look at it. It's fairly easy to understand. It's relatively easy to use. If you pair that up with the data grading tables that we have on our website, you should find the process fairly reasonable to get through and at least get you started with the water auditing. With that, I will put my contact information as well as Dawn's contact information up on the screen. As part of this project, we will be able to provide free assistance to small water utilities. Just as a reminder, under this project, a small water utility are those defined as serving 10,000 people or fewer. So if you're in that area and you would like some assistance, you're welcome to reach out to us and we will try to help you out. And one other thing I want to mention is we had some unanswered questions after the last webinar, and we will save those until after this webinar. And if we have any unanswered questions after this webinar, we will just combine them together and send out the answers to everybody after the webinar. So with that, I invite you, if you haven't already done so, to type in any questions in the chat box. And I will turn it over to Dawn to see if we have any questions from our audience today.
We do have some questions. The first question is, where can we get the M36 manual?
That's an easy one. The M36 manual can be purchased from the American Water Works Association. You can get it two different ways. They have a paper version, hard copy manual. They also have a PDF that you can get and just download to your computer. And you can actually get both if you prefer to have both versions, which I actually did. I like having one that's on my computer that I can take with me at all times, but I also like having the book because I'm still a tactile, old-fashioned person. So if you go to AWWA's website and look at their look at the portion of their website where you can buy manuals and books and that sort of thing, you will find the M36 manual. And again, you can buy it as a paper copy or as a PDF or both.
So I'd just like to add to that that within the AWWA free water audit software, there is an explanation of what all of the terminology is and what should be included in the calculations. So when you're starting with the free software, if you don't have, if you don't have the M36 manual sitting in front of you, there's a tab within the spreadsheet that you can use to look up definitions and look up, there's a question mark next to each little box, so you can click on it and it takes you right there to it.
Yeah, and I've just pulled up one of our slides just so you can see the question mark, and every single one of the items has the question mark. You can click on the question mark, and as Dawn said, it will bring up a definition, AWWA's definition of what that item means.
Another question is, can you briefly explain the ILI and how that is used to determine the value of the audit? I don't know that there's a brief explanation, but we are planning another webinar, so I think that we can definitely include that.
Yeah, the ILI is looking at, it's called the Infrastructure Leakage Index, and it's supposed to be a measure of how much water is leaking from your system compared to how much is what we call background or unavoidable losses. So it's kind of assumed that every utility has a certain amount of water that leaks through their pipes. Just when you put pipes in the ground over time, stuff is going to happen. So it's your weeps and your seeps. It's not your holes. It's not the water coming out under high pressure. So it's assumed that you can't find that kind of water loss by doing a leak detection program. So when we talk about background leakage, we're just talking about those weeps and seeps that are kind of unable to be found, and it's based on things like the number of connections to your pipe, the pressure, the total miles of mains, and that sort of thing. It won't be calculated for a very small utility that's outside the parameters of the equation. You won't even get that number calculated for you. But if you're a larger utility at a higher pressure, you will get that number. And it would be 1 if all of your losses were background losses. So basically saying your system is as tight as it could possibly be, that's a 1. If it's above a 1, say a 2, a 3, or 4, then you're saying, well, it's, you got some leaks you can address, but it's not too bad. If you start getting 5, 6, 7, 8, 9, 10, there's a very leaky system. So saying you have a lot more leaks than are unavoidable, so you should probably do something about it. There are occasions where the ILI will come out negative, and that's because the water audit software is calculating the real losses differently than the equation for background losses. So it kind of gives you a sense that that number is not able to be used well in that case. You kind of want to look back at your data and say, is my data as good as it could be? Are my production meters as good as they could be? So when you see a 1 for ILI or a negative value, that's probably time to look again at your data and see maybe your real loss number is not being calculated as good as it should. Very few systems are going to have like a tiny, tiny amount of water loss, although we have dealt with one recently, very, very small utility, all fairly brand new plastic pipe. They've had actually 2 or 3 leak detection surveys that were done by very reputable people, and they have found virtually no losses in their line. So when we did their water audit, they didn't actually get the ILI calculated because they were too small, but the real water loss came out as a really tiny number, and that's probably mostly background losses. That's atypical. Most utilities will have a much higher real loss number than the background leakage.
We had several other questions come in, so we will address those in email, so keep an eye out for that. I'm going to turn it back over to Savannah.
Thank you, Heather and Dawn. So quickly before we wrap up, I just have 2 more polling questions. The first one is if any of the attendees are interested in subscribing to the Environmental Finance Center blog. If you want to sign up for the blog but do not have the opportunity to submit your polling answer today, you can sign up for the blog on the EFCnetwork.org website. And I'm going to get ready to close that poll right now. And the next polling question is if you are a small water system of 10,000 or fewer people served, are you interested in receiving in-depth technical assistance? Again, if you're unsure about technical assistance or do not have the opportunity to submit your polling answer today, please review the technical assistance form on the EFCnetwork.org website. And getting ready to close that poll in 3, 2, 1. And lastly, Through the chat box, there is a survey link coming out to you all. If you could just take a few minutes to tell us what you thought of today's webinar, and also the AWWA CEU assistance emails in that chat box. I just want to thank Heather for giving such an amazing in-depth look into entering your data into the spreadsheet, and a thank you to Dawn for moderating today's question and answers. Thank you to all the attendees for joining us today. And Heather, I'm going to throw it back to you for any additional closing comments.
Just one last thing I would just mention is, based on the questions that we didn't get to today and the ones that we didn't get to from the last webinar, that will help us design webinar 3. But if there's anything else you would like us to discuss in webinar 3, feel free to email either myself or Dawn and let us know, what's on your mind. I'll kind of put our emails up real quick. Oops, kind of blew that one. Oh well, it's heatherh@unm.edu. If you think of anything that you would like to have included in the third webinar, we will be doing, that third webinar. Please let us know what kind of things you would like us to talk about, and we'll also cover the items that we didn't get through today with some of the data collection and the validity part, and then your unanswered questions. So if I can get it up here. Sorry about that. Oh, I did it again. Never mind. Anyway, just let us know if you have something you'd like to include in the third webinar. Be on the lookout for that announcement, and we look forward to having you with us again.